If you open up a traditional computer program, it is, it's like looking at a pristine engineering schematic. It's clean, it follows strict logical rules, and it just makes perfect sense.
Right, it's very predictable.
Exactly. But if you open up the brain of a modern artificial intelligence, that traditional map is completely gone. You don't find a database of facts. You literally just find billions of random numbers.
There's endless rows of decimal.
Yeah. So welcome to the deep dive. Today, we are stripping away all those Hollywood myths, the glowing red eyes, the supercomputers with personal vendettas, to answer the absolute deepest, most lingering questions about how this technology actually works under the hood.
And for the curious minds out there, and
Right.
if you're listening to this, you definitely fall into that category. We're going on a mission today to explore the hidden mechanics, the massive economics, and honestly, the mind-bending philosophy of AI.
We really are.
We're looking right past that slick chat interface you use every day to understand the actual machinery, because that is what gives you the knowledge to see through the daily hype.
So to do that, we kind of have to start with the physical reality, right? Before we can even ask what an AI creates or what it, quote unquote, thinks, we really have to understand how a machine like this stores information in the first place.
Yeah, that's the foundational piece.
Because as you just mentioned, it is not a database. There's no hidden text file inside a language model that says, Paris is the capital of France.
None at all.
Mm.
A language model doesn't store text anywhere. To understand what it actually does, you have to picture this vast, almost unimaginably large panel of dimmer switches.
Okay, dimmer switches.
Right, and not just a few hundred. We're talking about billions, sometimes trillions, of interconnected dimmer switches. And they are all controlling the brightness of this massive, complex lighting system.
Trillions. That is wild.
It is. And when you type a question into an AI, your prompt is basically like an electrical signal entering this grid. It routes through this giant web of switches and the final pattern of light that shines at the very end of the circuit that translates into your answer.
But wait, when the system is first built, before it's learned a single thing, those billions of dimmer switches are just set to random positions, right? It must be pure chaos.
It's completely random.
So if you ask a brand new, untrained model what the capital of France is, the lights just flash randomly, and it outputs absolute gibberish.
It outputs complete static, literally just noise. And the whole process of turning that static into a coherent answer is what we actually call training.
Ah, right.
Every single time the untrained system gets something wrong, it makes these microscopic mathematical adjustments to those switches. Like one switch goes up a fraction of a percent, another dims down just a tiny bit.
So it's tweaking them little by little.
Exactly. And done millions of times across billions of examples, the settings gradually converge into a really highly specific configuration.
And those settings are the numbers we talked about.
Yes, those dimmer settings are what computer scientists call weights. In physical reality, a weight is literally just a decimal number, usually between -1 and +1, stored on a silicon chip.
But wait, if the model starts as just random static and there's no, fact database, who or what is actually in the room telling the machine that its light pattern is wrong? Like, how does it know to adjust a specific dimmer switch?
Well, consider how human beings store highly complex knowledge. Think about a veteran surgeon performing a heart bypass.
Okay.
Where is that surgical skill physically located? You cannot point to a single neuron in the surgeon's brain that holds the instruction for how to hold a scalpel.
Right, it's not like a single file folder in their head.
Exactly. The skill is distributed across billions of synaptic connections, and it's been shaped and reshaped by thousands of hours of practice. The ability is the pattern itself.
Oh, wow.
Yeah, AI weights are implementing that exact same concept, just using silicon and mathematics instead of biological tissue.
Okay, so the knowledge isn't a file, it's the literal shape of the network. But that still leaves the question of how it practices. How does it know it made a mistake during that practice?
So the definition of a mistake depends entirely on the environment the AI is learning in. There are three primary methods here. The most common is supervised learning.
Supervised, meaning someone is watching it.
Basically. In this scenario, human beings label the data before the machine ever even sees it. A human takes a digital image and tags it with the word cat, or they look at a medical scan and tag it tumor.
Got it.
Then the AI looks at the raw image, runs its random dimmer switches, and makes a guess. Finally, it measures the mathematical distance between its random guess and the human's official label.
So that mathematical gap is the mistake. It's basically like a student taking a practice test while holding the answer key.
That is a brilliant way to put it, yeah.
The teacher isn't standing over their shoulder, but the teacher's knowledge is permanently encoded into the answer key itself.
Yes, exactly. The AI relentlessly measures its output against that answer key and adjusts its dimmers to shrink the gap.
Okay, so that's supervised. What's the second one?
The second method is unsupervised learning, which is honestly much stranger because there is no answer key. No human labels the data at all.
Wait, then what does it do?
The model is just turned loose on a massive pile of raw information and told to find the inherent mathematical structure entirely on its own.
But how does it know what a mistake is if there's no answer key?
It optimizes for efficiency. It looks for compression. It's basically asking its own mathematical algorithms, can I represent this giant data set in a smaller, tighter way? Or it uses clustering.
Like grouping things together.
Right. For example, if you feed it millions of animal photos without any labels, it will eventually realize that the pixel patterns of wolves and the pixel patterns of dogs are mathematically similar.
Oh,
So it groups them together in its virtual space. It doesn't actually know the word dog or the word wolf, but it knows they belong in the exact same cluster.
that is wild.
And if it randomly places a picture of a bicycle in the middle of the wolf cluster, the mathematical inefficiency of that grouping acts as the mistake, and it adjusts the dimmers to push the bicycle away.
It's just mapping the geometry of concepts. That's incredible. So what's the third method then?
Reinforcement learning. This is how we train AI to play complex games like chess or Go. The model is placed in an environment with a strict set of rules and a clear reward signal.
Like winning or losing.
Exactly. Winning the game is a positive reward. Losing the game is a negative reward. A mistake is simply any sequence of moves that results in a lower score over time.
So it just plays itself.
Yeah, the system plays millions of games against itself, using the final score to constantly reach back and tweak its billions of dimmer switches to favor the winning pathways.
Okay, so whether it's comparing against an answer key or clustering raw data or chasing a high score, the machine is just relentlessly processing data to fix its mistakes. Which actually brings us to a massive glaring problem.
Oh, the data source.
Yeah. If a language model needs to read billions of documents to adjust its switches, where is it getting all those documents? It's just scraping the internet.
The messy, unstructured, overwhelmingly massive internet.
Right. And the internet is full of incredible human knowledge, sure, but it is also full of terrible, toxic garbage, hate speech, conspiracy theories, massive biases, and just low-quality trolling.
Oh, absolutely.
If the AI learns purely by absorbing patterns, doesn't it just mathematically absorb our worst impulses?
Yeah.
I'm thinking back to 2016 when Microsoft released that conversational chatbot named Tay.
Right. Say,
They hooked it up to Twitter so it could learn from human interactions in real time. And within 24 hours, users realized it was just mirroring their language, so they deliberately fed it horrific, racist content.
it was incredibly fast.
Microsoft had to pull the plug immediately because the bot had become incredibly toxic.
Matt?
Doesn't the model just learn to be a troll?
Well, the Tay incident was a watershed moment for the entire field of computer science.
Hmm.
It proved unequivocally that garbage in, garbage out happens at a catastrophic scale when you were dealing with machine learning.
Right, because it doesn't know any better.
Exactly. The bot didn't have malicious intent. It simply had unfiltered data. If you train a multi-billion parameter model on a raw dump of the internet, you will absolutely build a system that reproduces the most toxic elements of humanity.
So how do we stop that now?
That specific engineering failure forced the industry to develop a rigorous three-layered defense system to ensure modern models are actually safe and useful.
Okay, walk us through those layers. How do you actually filter the entire internet before the machine learns from it?
The very first layer is literal data filtering. Modern training data sets do pull from massive web archives like Common Crawl, which basically copies vast swaths of the internet.
Right.
But before the AI is ever allowed to look at those words and adjust its dimmer switches, the text goes through really aggressive algorithmic scrubbing.
Scrubbing how?
Engineers write specialized programs to identify and strip out content that's flagged as extremely low quality, historically toxic, or just factually compromised.
So you take out the absolute worst of the garbage before the AI even boots up. But, I mean, that can't be perfect. Some bad data is definitely going to slip through.
Oh, it absolutely slips through, which is why the second layer is fine-tuning.
Fine-tuning.
Right. After the model completes its initial massive training run on the scrubbed internet, which is what teaches it the basic structure of human language and grammar, it's then subjected to a highly controlled secondary training phase.
Okay, so a smaller training run.
Yes. During fine-tuning, the AI is fed thousands of meticulously curated high-quality examples of how a polite, helpful assistant should act. It's kind of like taking someone who learned to speak by eavesdropping in a crowded dive bar and then putting them through a rigorous etiquette school.
That makes perfect sense. You shifted the center of gravity away from the messy web and toward, like, structured helpfulness. But I know there is a third layer, one that gets a ton of attention in the research papers.
Yes, RLHF, reinforcement learning from human feedback.
RLHF, right.
This is the crucial bridge between human values and machine math. Companies literally hire thousands of human raters to just sit and interact with the AI. The AI generates two different answers to a prompt, and the human rater chooses which one is safer, more accurate, and more helpful.
Wait, but how does a human clicking, option A is better than option B actually change the billions of dimmer switches?
It's clever. The human's choices are used to train a second, smaller AI, which is called a reward model.
Oh, an AI, training an AI.
Exactly. This reward model learns to perfectly mimic the human rater's preferences. Once the reward model knows what humans consider good or bad, it acts as an automated judge.
Wow.
It oversees the main AI, dispensing mathematical rewards when the main AI produces helpful text, and mathematical penalties when it produces toxic text.
So the main AI feels that penalty.
Right. It automatically backpropagates the signal, tuning down the specific dimmer switches that led to the toxic output. Now, no filter is perfect. Clever users can still find ways to trick the system.
Sure, people always find workarounds.
But the gap between a raw, unfiltered model and a modern system refined by RLHF is just night and day.
So let's take a step back and just look at the sheer scale of what you just described. We have billions of mathematical switches processing an archived copy of the entire internet, running algorithms to scrub the data, executing massive fine-tuning runs, and employing literal armies of human raters for RLHF.
It's a massive undertaking.
Doing all of that simultaneously requires server farms the size of shopping malls packed with specialized computer chips. The physical infrastructure has to be astronomically expensive. Who is actually paying to build this?
The organizations that can actually afford it are very, very few in number. Train what we call a frontier model, meaning the absolute cutting-edge systems pushing the boundaries of what AI can achieve. That costs hundreds of millions, sometimes billions of dollars.
Billions just for training.
Yes. You need tens of thousands of specialized graphic processing units, massive cooling systems, and incredible amounts of electricity. The capability to build these foundation models from scratch is heavily concentrated in a handful of massive tech companies.
Which feels incredibly restrictive. But, the analogy you hear in the engineering world compares this to the electrical grid.
That's a great comparison.
Like, building a nuclear power plant or a massive hydroelectric dam requires billions in capital, specialized land, and decades of expertise. But the electricity that comes out of the socket in your living room, it's cheap. Anyone can plug in a lamp and just read a book.
Exactly. The concentration of infrastructure does not necessarily mean the outputs are restricted to the ultra-wealthy. The distribution model for AI is actually highly democratized.
But history tells us this massive funding isn't guaranteed, right? I mean, we have gone through periods known as AI winters.
We have, yes.
Back in the 1970s, and again in the late 80s, the hype outpaced the technology. Researchers promised human-level intelligence, but they simply didn't have the computing power or the data to back it up.
And the funding dried up.
Right. When the deliverables failed, the investors vanished, and the entire field went into a deep freeze for decades. If the current technology is controlled by just a few massive corporations, couldn't a change in the economic winds plunge us into another AI winter?
It's a valid fear, and the historical context is vital. But the economic reality today is fundamentally different. During the previous AI winters, artificial intelligence was largely an academic pursuit.
It was mostly theoretical.
Right, it was contained in university labs running on government research grants. Today, AI is actively embedded in commercial products that generate massive, real-world revenue.
Like actual tools people pay for.
Exactly. There are coding assistants right now writing substantial portions of software for global development teams. Search engines, logistics networks, and medical imaging systems are deeply reliant on these models. Pulling funding today wouldn't just end a science experiment, it would rip out the core infrastructure of the modern digital economy.
So a total freeze is pretty much off the table because it's too baked into the system.
A total freeze is highly improbable. However, a massive slowdown is entirely possible.
A slowdown?
Yes. The industry currently operates on the assumption that scaling up, like throwing 10 times more compute and 10 times more data at a model, will yield a proportional leap in intelligence.
But what if it doesn't?
Exactly. What if we hit a scaling ceiling? What if spending $1 billion only yields a 2% improvement instead of a 200% improvement? If the returns diminish, the massive capital investments will absolutely slow down.
That makes sense.
Additionally, a severe safety failure could trigger heavy government regulation, which would drastically slow the pace of deployment. But even if the frontier slows down, the access we already have is deeply entrenched.
Right, the socket in the wall is already installed and the electricity is flowing.
Exactly. A solo software developer sitting in a cafe in Lagos or São Paulo can access the most powerful frontier models in the world using an API.
Just over the internet.
Right, an API, an application programming interface, is basically a digital bridge that lets a simple laptop send a prompt to a multi-billion-dollar supercomputer in the cloud and receive an answer for a fraction of a cent.
That's incredible access.
Furthermore, we're seeing an explosion of powerful open-source models. Companies are releasing highly capable models for free. Small startups can download these models and run cheap fine-tuning on their own private data, like a local law firm training an AI purely on their own legal briefs without needing to build a supercomputer.
So, assuming this accessible ecosystem continues to thrive and people all over the world are using these models to generate code, write emails, and draft essays, we really have to ask what exactly they are generating.
That is the big question.
If the AI was trained purely on a heavily filtered archive of human data, is it actually creating anything new? Or is it just regurgitating the internet?
You are touching on the single most fiercely debated question in cognitive science and copyright law right now. What is the actual nature of AI creativity?
Well, think about a human jazz musician. When someone wants to learn to play jazz trumpet, they don't just pick up the instrument and invent a new genre from scratch. They start by copying.
Right, emulation.
They listen to a Miles Davis record and transcribe the solo, playing it note for note. They absorb the scales, the phrasing, and the vocabulary of jazz through pure imitation. That sounds exactly like supervised and unsupervised learning.
It's very similar, yes.
But eventually, that human steps onto a stage, they stop thinking about the scales, and they improvise. They play a sequence of notes that has never been played before.
They are taking the patterns they absorb through intense imitation and recombining them in response to the immediate moment. They synthesize a genuinely novel expression.
But is the AI actually improvising? Human creativity is driven by intention, emotion, and lived experience. A human musician plays a sad note because they have literally felt sadness. The AI has no body, no history, and no feelings. To generate a word, it just uses what engineers call statistical token prediction.
Right, let's define that clearly. A token is simply a fragment of a word. Think of it like a syllable.
Okay.
The AI is not thinking about grand concepts. It is calculating the mathematical probability of which syllable should logically come next, based on the billions of dimmer switches we talked about earlier.
Right, so if it's just predicting the next syllable based on its training data, is it really being creative? Or is it just the world's most sophisticated copy and paste tool stitching together other people's work?
It is absolutely not a copy and paste tool. It is not acting like a traditional search engine that finds a specific paragraph someone else wrote and just retrieves it.
It's not just looking things up.
No, because the model has absorbed patterns at a scale no human could ever match. The underlying mathematical geometry of legal arguments, romantic poetry, and Python code. It can recombine those patterns into completely novel outputs.
So it's synthesizing.
Yes. If you ask it to write a Shakespearean sonnet about a modern smartphone, it doesn't find a pre-written poem and copy it. It applies the mathematical pattern of a sonnet to the mathematical pattern of a smartphone and generates a specific sequence of tokens that no human being in history has ever produced.
So the novelty comes from the sheer complexity of the synthesis. It's mashing up concepts in a way that is mathematically unique.
Precisely. It lacks human intention, and it absolutely lacks emotional depth. But the physical act of applying deeply learned patterns to completely new contexts sits right at the very edge of how we define creativity. It forces us to ask if creativity is a mystical human spark, or simply the complex recombination of prior knowledge.
And that leads directly to the most uncomfortable realization of this entire deep dive. If a machine can improvise a novel, beautifully structured output, say, an incredibly moving essay about the grieving process, without possessing a single ounce of lived experience, it really forces us to confront the nature of understanding itself.
Philosophers and computer scientists have been colliding over this exact point.
Because when the AI generates that essay about grief, it has never felt loss. It doesn't know what it means to cry. Its entire knowledge of grief is just the mathematical proximity of certain tokens, right? Like the word tears is statistically likely to appear near the word loss.
That's the mechanism, yes.
So no matter how beautiful the essay is, the AI doesn't understand what it is saying. It is just incredibly perfectly good at faking understanding.
The prevailing scientific consensus would absolutely agree with you. It is a statistical illusion.
Yeah.
But the counterargument is where things get truly profound. I want you to examine your own premise for a moment.
Okay, I'm listening.
How do you know that human understanding isn't also, at its most fundamental physical level, just incredibly complex pattern matching?
Wait. What?
Think about the biological reality of your own brain. Your profound, deeply felt sense of understanding a concept is, physically speaking, the product of neural activity.
Right.
It is electrochemical signals propagating through biological tissue, ions flowing across membranes. What exactly is the magical ingredient that makes your biological neural processing real understanding, while an artificial neural network doing mathematically similar processing across silicon chips is just pattern matching?
Are you telling me the only difference between my brain and a server farm is that my dimmer switches are made of biological tissue? That is profoundly unsettling. You're just reducing human emotion to biology.
I am pointing out that this directly intersects with what philosophers call the hard problem of consciousness. Science can map the brain, we can see the neurons firing when you feel sadness, but we have absolutely no idea how or why those physical, chemical processes give rise to a subjective, internal experience.
We don't know where the feeling comes from.
Exactly. The jump from physical matter to conscious feeling is completely unsolved. And until we solve the hard problem of consciousness for ourselves, drawing a firm, undeniable line between an AI faking it through complex statistics and a brain actually doing it through complex biology remains a massive, open philosophical puzzle.
That is heavy. It really forces you to look in the mirror. Let's take a breath and recap the incredible journey we have just taken under the hood of this technology. We started by stripping away the magic, realizing that AI isn't a database of facts, but a physical configuration of billions of mathematical weights, those tiny dimmer switches.
The foundation of it all.
We learned that these switches learn by measuring mistakes against an answer key, clustering concepts, or chasing rewards. We explored the massive engineering challenge of filtering the messy internet, using human feedback to literally dim down the toxic patterns and brighten the helpful ones.
And we saw the economics driving it.
Right. We saw that while the massive supercomputers required to do this are incredibly expensive, digital bridges and open source models are making the power accessible to anyone. And finally, we saw how statistical token prediction generates outputs so novel, they force us to question the biological roots of our own creativity and consciousness.
And if you are listening to this, the reason all of this matters to your daily life is empowerment. Understanding these underlying mechanics is your absolute best defense against the endless cycles of hype and fear-mongering.
It really is.
When you use an AI tool at work, or when you see a sensational headline about the latest breakthrough, you aren't looking at a magic trick anymore. You know exactly what is happening in the circuitry, you understand the limitations of the data, you see the economics driving the servers, and you grasp the philosophical illusions at play.
You can see the dimmer switches behind the curtain.
Exactly. Knowledge dispels the magic, and it leaves you with a tool you can actually control.
But before we go, there is one final provocative thought I want to leave you with, something to mull over the next time you open a chatbot. We have spent this whole time talking about how AI learns by absorbing the massive human-generated patterns of the internet. But what happens over the next 5 years?
That is the million-dollar question.
The internet is rapidly filling up with synthetic text code and images generated by AI. Soon, the vast majority of the data online might not be human at all. When the next massive frontier model scrapes the web to adjust its billions of dimmer switches, it will be learning from data created by other AIs.
An endless loop.
It will be a machine training on the output of a machine. If the AI is just endlessly processing its own artificial reflections, what happens to the output? Does it evolve, or does the reflection eventually distort? Keep questioning the reflection. We will see you next time on The Deep Dive.